Greetings once again. Today we'll take another walk on the wild side. This chassis, it's time to get it clean. It's kind of mangy looking. It's got there's probably a cadmium coating on this radio because it has a greenish hue to it. Now cadmium, I understand, can be toxic, but I'm not going to stick my fingers in my mouth, so I just don't get excited over it. The way some people talk, you touch it once, you're going to drop dead. It doesn't work that way. I'll be using my old standby. For those that don't know, I do use navel jelly to clean the chassis. It's slow, and I use a Q-tip. I pour it into the top and then just smear it around a little bit. And then take a wet rag after it's set for a while, which I have right here. It's all wet, an old wet towel. And I let it set and then wipe it off. And sometimes I have to put more than one application. But that's the way it is. It's slow and it's tedious, but the results for me have always been good. One more thing I want to tell you about restoring old radios. There's a million different ways to do it. My way is not the only way. I'm simply showing you the way I do it. Every one of you, if you ever restore a radio, buy a radio restore, whether it be a small radio, a large radio, every one of you are expected to do better. While I'm cleaning the chassis, all I'm going to do, I'll give you a quick rundown what I'm going to do. I'm just going to smear it on here like so. Just let it set for a while and see if I can't get rid of some of that crap on there. Just let it kind of sit there for, I don't know, 10-15 minutes. Just kind of take my time. Incidentally, if you ever decide to use navel jelly, don't get it on aluminum. It messes it up. And don't get it on chrome. It also messes that up. It says so right on the back of the bottle. Don't get it near aluminum or chrome. It'll mess it up. So while I'm playing around here, dabbing here, dabbing there, trying to see if I can get some of this crap off of here, I thought we'd cover maybe another part in the chassis and its relative position on the schematic. So let's do that. Practice makes perfect, In order to help you with color codes on resistors, making things much, much faster, there's a website out there that you can find by typing in 4-band resistor color codes. It's got a real long name, and you just type in 4-band resistor color codes. And that'll take you to this little jewel here. And this is one of the handiest little things. I just use it all the time. For instance, let's go over here in the chassis and select this resistor right here. Another dog bone. Let me get this light out of our way a little bit. Have another dog bone. It would be, remember I told you body and dot? Okay, in this case the body is red, the end is black, and the dot is orange. Red, black, and orange. Let's see what size that is according to our little handy dandy deal. You take and put you click here first. See, there's an arrow down here, and it follows each. So click here to set your first stripe. And we said it was red, black, and orange. So now we've got the arrow in place for the first band. We come over here and we click red. Then we go up, and the arrow automatically moves to the next band. And we'll go ahead and, let's say that was not black, we'll just go ahead and click black. And now it moves over to the last band, which is orange. We would go over here and click orange. Well, of course, most of this was already set up. That is a 20,000 ohm resistor. Right there it is. 20,000 ohm resistor. And I just love using this website and for figuring out my resistances. We're going to use it a couple more times here in a minute. Here you can see on the schematic there's a little gauge right there, and it's got a resistor that goes around it. It's called a shunt resistor. And that little gauge you're looking at right there is the shadow meter. And it has a little 4,000 ohm resistor shunting around it. You'll recall that the red and black wires that I cut that went to the shadow meter went down through the chassis, I told you, along with the power wire for the light bulb. Well, here they are coming down through the chassis, and you'll see that this red wire is hooked to one side of this resistor, and you'll see that the black wire that comes out of here is hooked to the other side of this resistor. Now this resistor is another dog bone, a little larger. I believe it's a 1 watt, whereas this one here is a half watt. You can see the difference in size. This would be a half watt. This one's a little larger. It's a 1 watt. So we've got, again, the BED. We've got yellow, black, and red. Body and dot. So let's see if that comes out to 4,000 ohms as shown on the schematic right here. Let's see if that works out. Yellow, black, and red. Here we go. Back up to our little resistor. Click once to set your arrow. First stripe, yellow, black for the second one, and red for the third one. Look at there. 4K, 4,000 ohms. That resistor right there is that resistor right there. That's the shunt resistor around that shadow meter. Now let's go a little bit further. If we follow this thing down, we see that there's a long burnt looking resistor right here. It's probably a 2-watter, and it is, if you follow the wire up, it's kind of hard to see with all the dust. It's connected to the other side of this shunt resistor. It's a 2-watter, and it's difficult to tell the color, but it looks like the body was yellow at one time. It's been burned. It took a lot of heat. I may have to put a larger wattage resistor in there. But the body shows yellow, and the cap or the end shows black. I don't see any dot anywhere that tells me what the third color is. So now we have to refer to our parts list. Not every radio you work on will have a really nice parts list like this one does, and it will not have a parts placement diagram to show you where everything is at. Fortunately, Chuck Schwartz was able to supply me with both. Like I said, it was well worth the $7 investment. Now I look right here on this diagram, and I see this larger resistor right here. Now that larger resistor is that one right there. Okay? And according to the number associated with it from the arrow, it is part number 57. 57. So let's go to part number 57 on the list, and it says that it is a, remember I told you it was yellow. It had a yellow base, a yellow body, and a black end, but I don't see any dot there. Now you come over here to 57, and it says it's yellow. It's a 4,000 ohm resistor. It is yellow, black, which is what this is, yellow and black, and the dot should have been red. Yellow, black, and red. 4,000 ohms. It's the same size as this one right here, only this is a 1 watt, this is a 2 watt. Both of them are 4,000 ohms. Well, let's ohm that thing out with the old multimeter and see what we've got. Once again, I've got my alligator clips hooked to each of my multimeter probes, and I've got the multimeter set to 20,000 ohms, or 20K ohms. We're looking for 4,000. The scale down below it only goes up to 2,000, so I need something higher. And we don't need to use the 200,000 scale. We could use it, but 20,000, much better. So let's go ahead and hook this thing up. And we're measuring the resistance of that black looking resistor right there next to that capacitor. It's looking real bad, real bad. If I can get this lamp down here where you can see it. There it is, there. So what we're going to do is hook, it's soldered to this connector here, and it's soldered to that connector there. So what we're going to do is hook one of our multimeter wires to one, and we will hook our other multimeter wire, alligator clip, to this one. Make sure we got a good solid connection. Okay, we now have that resistor right there connected between these two wires, which are connected to the multimeter. We're supposed to have 4,000. Let's see what we got. Yeah, man, not good at all. 2,540 or 30. That resistor's no good. 2,540. Not good. Hope you can see that. Let me get this light up a little further. There we go. Okay? On the 20,000 scale. So I'm going to have to yank that resistor out of there. Now I told you a while back that most resistors, when they get old, the resistance goes up. Well, that's true. Unless they've been overheated or burned, which is the case of this resistor right here. Now I'm going to go ahead and replace that, but I'm not putting a 2-watt in there. That thing got pretty hot over the years. I'm going to put a 5-watt in there. Tell you what, since we still have the multimeter hooked up, let's go ahead and check out this 4,000 ohm shunt resistor also. We know this one's no good. Little black thing there. Let's check this one out. Same procedure. I've got the multimeter set to 20,000 ohms. Now this one is hooked up. It's got a lead that comes this. You can see it's got long leads on it. They come way out here and way down there. So we're going to go ahead and hook this up right there. And we will hook the black one up down in here to the other end of that long set of leads. There again, wiggle it around, make sure you got a good solid connection on there, good solid bite. Sometimes there's so much dirt on these contacts that you think you got a bad resistor when what's happening is the dirt is so thick and cruddy that you're not getting a good connection with your alligator clip. So make sure you always have good solid connections. No sense in replacing resistors that don't need replacing. Let's take a look at the multimeter. 3,910. That's a good resistor. We'll go ahead and keep that one. It's within tolerance of what I use is 20%. That's pretty cool. Now some people just go ahead and replace them. You say, look, I'm not keeping those dog bones in there. Generally speaking, I don't. If I was going to give this radio to a third party, or a second party, I guess I should say, if I was going to give it away, I would probably replace these resistors. I don't want to take any chance of anybody, any smoke being, any fire, anything like that, anything that might ultimately harm someone. I mean, it's up to the individual. If you don't like them, if you don't trust them, get them out of there. Replace them with new modern resistors. But since this is going to be my radio and it'll be sitting on the bench and I'll be the only one who ever operates it, if something were to happen, I know what to do. Well, I hope you enjoyed our second excursion into the bowels of our chassis. Meanwhile, the old navel jelly's been sitting here. I've been kind of working it around a little bit from time to time, adding it a little more jelly here, a little more jelly there. The idea here is to keep it wet. We're starting to get a nice looking surface here. Just give it a nice wipe down. Looks a whole lot better than it did, I'll tell you. Look at there. Look at there. Oh yeah, she's starting to perk up good. Now this will, I'll probably have to do another good long soaking of navel jelly here and there, especially on the rusty areas that are a little. That's not too shabby. We're getting there. Interesting thing I wanted you all to see here. Right here on the side of this chassis. Let me get that light down close. Look where that thing has all been cut. I can't figure that out at all. At first I said, well, maybe that happened at the factory. But no, it didn't. That was a fresh set of cuts with a pair of cutters of some kind. You know, I was sitting here thinking and thinking, trying to figure out what on earth would someone have had to do that for. I can't come up with an answer. I'm open to suggestions on that one. Fortunately, they didn't cut all the way through. I don't know, maybe they wanted to put a larger transformer in there. I don't know. Can't figure it out. Okay, she's not looking too bad. I got it all wiped down. I'll probably spend the next couple days cleaning and, you know, putting new navel jelly on, and we'll wrap this video up right here. I did have one of my wires break off from around this hole down here. You know, where does that go? Who knows?